Hello everyone, welcome to Digital Electronics lecture series. This is lecture number 19. In previous lectures we studied the ways to solve K-maps, the various properties, pairs, quads, octets. Now we will see how to solve this K-maps. We are given a function, so it is given reduce the following logical function using K-maps. So we are given f of ABCD equal to sigma small m 0, 1, 2, 3, 7, 8, 9. Now this small m shows that it is a SOP. We have to draw SOP K map, and this number 0, 1, 2, 3, 7, 8, 9 should be put as number 1. Should as high. It is 1. So if we remember the cell representation of a K map, I will just draw it here again for just revision. That for a K map, the cell numbers are such that this is 0, 1, 2, 3, then 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So these are the cell numbers. So now I just put here, this is the required K map. So this is what we have. Okay, SOP A bar B bar. So this is SOP K map. Now whatever this number, cell numbers, this cell number, this the first one is, I will just mark it with green. So this one, this position, this one 0, then this is 2, 3, and then 7, 8. So here we have 7, then here we have 8, then 9. This all should be 1. Okay, rest all should be 0. So let us put the values here. So this was 0, this is 1, 1 is 1, 3, 2, then 7 is also 1, then 8 and 9, and rest all are zeros. So for SOP we have to put all these cell numbers as 1 and rest all as 0. Now after drawing the K map, we will check whether we are getting octet. So whether first preference is whether we are getting any octet or we are not getting an octet. Let us check, are we getting any quad? So yes, we get one quad here. This is one quad, so we encircle this quad. Then this one, these two ones, they can be rolled. Okay, we can use the rolling property. This can be rolled, so that we can have one more quad. Now this one, okay, it is alone, so we can use this one more than once, so there we have a pair. So here in this case we have two quads and a pair. Let us write the equation of the quad. The equation of this particular quad is A bar B bar, or then equation of this particular quad we see from when we go from this one to this one, A is changing, B bar is common, and here C bar is common. So the equation of this is B bar C bar. So this is the answer. This we have reduced using the K maps. Now this is the second example. Here we have D is the don't care. So this is a SOP K map, because we have f of ABCD is sigma small m. So small m is this, all these numbers 0, 1, 3, 4, 7, 9, 15 should be 1, and this 2, 8, 10, 11, they represent the don't care conditions. So let us first draw the K map. I'll put the entries. So 0 comes here, so this is 1, then this comes here, then 3 is here, then next is 4 comes here, then 7 comes here, then we have 9 comes here, and then finally 15. So this 15 comes here. Then we put the don't care is at 2, so 2 is here, 2 is a don't care, sorry, this is a don't care. Then 8 comes here, so 8 is a don't care. Then 10 is a don't care, so it comes here, and then 11, so this is 11 is a don't care. Now rest all are zeros, so this all zeros, this all are zeros. So now, as we know, we can take don't care for our advantage. If we are getting advantage, then we can consider don't care as 1, otherwise they can be left as 0. So first of all, are we getting any octet? Okay, yes, we can see there is an octet. How we are getting an octet here? You can see, if we consider this particular x don't care, and this don't care, and this don't care, and this don't care as 1, then we get a octet by rolling. Okay, so this rolling, this by rolling this, we get a octet. Okay, so octet is better than a quad, and quad is better than a pair. So the first priority is we should see if we are getting any octet. So we are getting an octet, very a good advantage we are getting. Next, we have to take care of these 3 ones now. Now in this 3 1, can we find octet? So we don't find octet, but we find a quad. So this is a quad. Okay, this don't care can be used again, and this one can be used again. Now with respect to this one, we can't find any quad, so we are left with a pair. So now here what we observe is, in this case we have a octet, a pair, and a quad. So the equation y equal to, first we write the equation of this octet. So in this octet, b bar is not changing. Okay, so if we observe this, I will, if you want to draw, I'm drawing it against the blue one. So this is the octet, this octet, this one. So in this case, b bar, or now we write the equation of this particular quad. So this is CD, and then finally the equation of this pair. So in this pair, B is changing, so we have A bar, C bar, D bar. So this is the answer. This is how we reduce this equation. Now if we consider the third example, reduce the following logical function using K-maps. F of ABCD is capital sigma capital M 0 1 4 5 8 9 13 15. Now this capital M, it shows that this is a POS. We have to draw a POS K-map, and this numbers, they should be, the cell numbers, they should be 0. So we have, this is a POS K-map. Now we do the entries. Okay, whatever this cell numbers we have with respect to this particular case, we have to put it as 0. So 0 will come here, and change the marker, take the yellow one. So this is 0. Okay, then 1 is 1 here, 1 is here, then 4, then 5, then 8 9. So 8 is here, 9 is here, then 13. So this is 13, and finally 15. So this all are 0, and then our rest all are 1 1s 1. Now in this case we have to encircle zeros because it is POS. Now let us check whether we are getting any octet. Octet is not there. Are we getting any pair? Quad. So here we have a quad, a straightforward quad is here. We are getting a quad here. Then we can combine this also to make up a quad. Then here, okay, we can roll this. Okay, we can roll this to find one more quad. Now this 0 remains, so we can only make a pair. So here we find there are 3 quads and a pair. So we write the equation of this. So what the equation is, y equal to, first I write the equation of this particular quad is straightforward, C or D bar. Then equation of this particular quad, A is not changing and C is not changing, so A or C. Then equation of this particular rolled one, so in this A is changing, so B or C. And the last one is this pair. So a pair eliminates one variable, so this equation C gets eliminated, so we are left with A bar or B bar or D bar. So this is the final answer. This is how we reduce using the K-map. Now let us see one last example. So here we have f of ABCD equal to capital sigma capital M 1 2 4 7 8 9 dot D. So this D means don't care. So in case of SOP we have small m, and here there is a or plus sign, but here there is a dotted and sign. So D 0 13 and 15. So we put the zeros first. All these cell numbers, they should be 0. So 0 will come here, then 2 is here, so 2 will become 0. Then we have 4, this 4 will become 0. Then 7 comes here, 7 becomes 0. Then 8 is here, 8 becomes 0. Then 9 becomes 0, this is 9. Now then we have 0, so this is 0 is a don't care. Then 13 is here, 13 becomes a don't care. And finally we have 15 is also don't care, this is also don't care. Now rest all are ones, this is 1, this is 1, this is 1, this all are ones. Okay, now let us check whether we are getting any octet. There is no octet. Okay, now let us see if we are getting any quad. Okay, so here we find if we roll this if we roll this, we get a quad. Okay, we get a quad. Now with respect to this 0, we can't find a quad, so we need this is a pair, it forms a pair here. Then here this 0 is left alone, but we can roll this in this way, so we have one more pair. And now this 0, it can form a pair with this particular don't care. So this is how we solve it. And now we have one quad and 3 pairs, so we all the zeros are covered. Okay, so we don't use this particular don't care because we don't have any advantage using this. Okay, it is left as it is. So now we write the equation. So equation first, we write the equation of a quad. So in this case the equation of this particular quad is B or C. Then equation of this particular pair is A is changing, so we have B bar or C bar or D bar. Then we have this particular if we see the pair, we have C is changing, so we have A or B or D. Then finally this particular pair, so here what we see is B is changing, so we have A or C or D. So this is the final answer, we get this. So that's all for this session. We have solved 4 K-maps. Now we will be solving more when we design a circuit. So we must learn this technique very efficiently. Okay, so learn this properly, because for designing circuit we will be using K-maps throughout. So thanks for watching.